An introduction to polynomials. The number 5 is a polynomial of degree 0. It is a constant. 3x is a polynomial of degree 1. There's an invisible exponent of 1 on that x. It is a linear term. 2x squared plus x minus 4 is a polynomial of degree 2. This 2 right here is the highest exponent in the polynomial. So it is a polynomial of degree 2, and the degree determines the shape. This polynomial, when graphed, will look like a quadratic. Exponent of 2 will make a u when you graph it. Linear will make a line. Constant, if you graphed it, it would make a horizontal line. Next polynomial has a degree of 3 because the highest exponent in the polynomial is 3. For the next polynomial, we actually have 2 terms that have a degree of 3. We would combine like terms, and that would be 30x cubed. And after we put them together, the entire polynomial would have a degree of 3 because it is the term with the highest exponent that determines the degree. So this would be a cubic, kind of like a parabola, but with the negatives pointing down. Next, we have a polynomial of degree 4. And it would be a quartic, which would start high and end high. The parent quartic would look skinnier than the quadratic, but then it depends on the transformation. An example of something that is not a polynomial. This looks like a polynomial, but it is not, because to be a polynomial, you can have no negative exponents. So not a polynomial. The next one is not a polynomial because of this right here. The exponent on this x right here is actually 1/2. No fractional exponents. This one is not a polynomial because that no x is on the bottom. An x on the bottom is really a negative exponent, so no negative exponents. The rules no negative exponents and no fractional exponents apply solely to the variable. This next one is a polynomial. Notice all your variables have no negative exponents and no fractional exponents. It's okay to have a square root. It's okay to have a number on the bottom, but you cannot have a negative exponent or a fractional exponent on your x term. Next, put the polynomial in standard form, starting with your term of the highest degree and then working your way down. 2x cubed has the highest degree plus 3x squared minus 4x, invisible exponent on the 1, plus 7x. The last thing to do with this one is we should combine like terms. There's our polynomial in standard form and simplified. What does the distributive property look like? If we are going to distribute this thing in front, we would take this and multiply it by the first term in the second pair. We would take this and we would multiply it by the 2x. And then we would take it again and multiply it by the 5. You can see here that this was first multiplied by the 2x, and then it was multiplied by the 5. Now, we're going to stop here, but to finish the problem, you would really now distribute all of these. If you see something that looks like this, that is identified as the first step of the distributive property. FOIL is where you do first term, outer pair, inner pair, last pair. FOIL is where you do first pair, outer pair, inner pair, last pair. First pair, outer pair, inner pair, last pair. If you see something like this, this is the first step of FOIL. Multiply the following using vertical multiplication method. We need to start with the -2 and multiply by all these terms. -2 times -5 is +10, so we've multiplied the -2 times all the terms. We're going to block out this space right here. We're going to take the x and multiply it by the top terms. The next step is to add down. Notice we're going to have +10, -11x, +x squared, and x cubed. Which of the following equations demonstrates that the set of polynomials is not closed under that operation? Let's add these two monomials and see what happens. 3x squared plus 5x squared gives us 8x squared. Notice when you add terms, you add the coefficient and do not change the exponent. Subtraction. 3x squared minus 5x squared is -2x squared. Notice when you subtract, You subtract the coefficient, you do not change the exponent. So we've taken a polynomial and added a polynomial, and we still have a polynomial. So far, we have no broken rules. And what are the rules for polynomials? No negative exponents, which is equivalent to saying no x's on the bottom. Rule number 2, no fractional exponents. Multiplication of polynomials. You multiply the coefficients and you add the exponents. So I took a polynomial times a polynomial and I got a polynomial. There is still no broken rules. Division. I take a polynomial divided by a polynomial. I have now jumped out of the group of polynomials because this breaks the rule. Remember, no variables in the denominator.